The Solow growth model explains why countries' income levels and growth rates differ, and concludes that countries are different because they have different savings rates, population growth rates, and rate of technological progress. The main conclusions from the Solow growth model are: 1. Savings rates, population growth rates, and technology explain why some countries are rich while others are poor. 2. Changes in savings rates or changes in population growth rates explain short-run and medium-run growth rates. And third, the rate of technological progress explains long-run growth. These are important conclusions, and the Solow model clearly shows that the determinant of long-run economic growth lies in technology. However, the Solow model by itself does not explain growth, since the savings rate and the population growth rate and technological progress are all exogenous to the model. That is, these variables explain growth, but they themselves are not explained in the Solow growth model. For example, why do savings rates differ across countries? Why do population growth rates differ across countries? Why do rates of technological progress differ across countries? And once we have saving, where should we invest the money? These are obviously important questions, and part of the answers involve having proper institutions and good incentives. But the Solow growth model cannot explain them. Anyway, at this point, we want to focus on the variable that is believed to be responsible for most of observed differences in country growth rates, namely technological progress. Solow's neoclassical growth model shows that long-run economic growth is only possible if there is technological progress. Technically speaking, the way the Solow model works is that exogenous technological progress overcomes the effect of diminishing marginal returns to capital and labor. Without technological progress, diminishing marginal return will condemn all nations to zero growth in per capita output. Technological progress can overcome this dismal prediction. As an interesting and perhaps important side note, up until 1800, there was virtually no growth in per capita real output. It was not until 1820 that such growth started. After 1820, per capita output levels have been increasing exponentially. So we must ask ourselves, what happened around 1820? Well, the main event that took place in the world around 1820 was that people began to learn how to do things more efficiently. They developed better tools, better products, etc. That is, the Industrial Revolution took place between around 1750 and 1850. Since then, the world has created new methods, new tools, and new ideas at an accelerating pace, and the result has been rapid growth of per capita income. Because of this fact, we believe that any economic growth model must include technological progress as a major source of economic growth. Solow, of course, did this, but he was forced to merely assume exogenous technological progress. That is, Solow explained long-run growth by using a variable that he did not explain. In response, economists have developed models that attempt to explain technological progress. These models are called endogenous growth models because they endogenize the process that causes technology to change. Let's just take a minute to reflect on what we mean when we say technology. It is actually difficult to model the growth of technology. We might think of technology as being associated with a particular type of products or a particular industry, like iPads and the computer industry. But this is inaccurate. Technology is a much broader and much more expansive concept. Technology represents anything that will allow an economy to produce more output using the same amount of input or produce the same amount of output using fewer inputs. This includes all kinds of ideas. Of course, innovations and inventions are included, but any idea that allows us to produce more using fewer resources will be considered technological progress. As an example, all of these are considered technological progress. Basic inventions. For example, invent electricity. Invent applications of discoveries, like inventing the light bulb. Enhance existing applications, like make a soft white light bulb. Improve the quality of production, like make better soft white light bulbs. Reduce the cost of production. Use fewer resources to produce light bulbs. Adapt discoveries to other areas of the economy. Learn how to use light bulbs differently. And improve how an economy allocates its scarce resources. That could be improving political, legal, and economic institutions. Understanding that technology is more than just better computers is important, because if we think of technology as computers or other high-tech industry, then it is very easy to conclude that to promote technological progress, we need to promote our high-tech industries. And this is not the best policy for developing nations. Again, a better way to think of technology is to think of it as ideas, any kind of ideas. The general approach of endogenous growth theory is to assume that technological progress is incremental. That is, it occurs continuously in a long series of small steps that build on each other. The easiest way to incorporate technological progress into an economic model is to assume that technological progress is an externality to some other variable in the model. One model that does this is called the Romer model, and it picks up exactly where the Solow growth model ended. Let me give the intuition behind the Romer endogenous growth model. We suppose that investment in physical capital at the firm level increases the total level of labor augmenting technology in the overall economy. That is, when my firm becomes more productive, I make all other firms more productive as well. We view technology as being embodied in the equipment and machines used in production, and although each firm takes technology as given, exogenous, its actions make all firms more efficient and more productive. Thus, any firm's investment in capital create a positive technological externality that benefits all firms and the entire economy. This increase in efficiency acts to replicate the role played by surplus labor in the Harrod-Demar model, and therefore overcomes diminishing marginal returns effect that the initial investment in capital should have generated. This effect allows an economy to grow in per capita income forever. This explains the fact that countries have indeed grown over time, and they seem likely to continue to do so.